Not so long ago, Microsoft's strategy was to try to wedge Windows into everything. Digital signs, vending machines, cars, which gave us a whole new fear of the blue screen of death, and many more devices. But these days, Microsoft has a different and more nuanced edge computing strategy, and one that we're going to hear lots more about in the evolving AI era. Welcome to the Directions on Microsoft Briefing Podcast. I'm Mary Jo Foley, the editor-in-chief here at Directions. I'm your host for the series of podcasts for those interested in the Microsoft Enterprise IT ecosystem. My guest for today's episode is Directions analyst Barry Briggs, who's the former CTO of Microsoft's own IT unit. Hi, Barry. Thank you so much for doing the podcast with me today.
Hi, Mary Jo. Great to be here.
All right, let's just go right in here and say, what do we mean when we say edge computing?
Sure. We've been through, I would say, a pretty major transition over the past 10 years or so. We've been spending millions or tens of millions of dollars migrating IT systems from on-premises data centers to the cloud. And along with this titanic change came a whole new set of application architectures, storage models, networking, and so on. And for quite some time, the prevailing IT wisdom was simply put everything in the cloud. But, it kind of became obvious pretty quickly that there are certain types of workload that maybe shouldn't be run in a centralized data center hundreds of miles away from your site. Where you might have, some specific requirements, like you might have a medical device where you must have precise latency. Or my favorite example, you think of a hydraulic press at a manufacturing plant that, you slide in a piece of metal every 3 seconds and pull out some finished part. You have to have exact precise latency, or somebody's going to stick their hand in and we're going to turn their arm into a quarter panel on a Chevy.
Yep.
So, latency is really important here. Deterministic latency, what I call, is really important. There are other requirements. In some cases, you might have regulatory requirements that say, certain types of data can't be put in the public cloud. You might have, problematic connectivity, if you're on a cruise ship, for example, so connectivity might not be reliable, but we still want to be able to manage such systems, provision them, monitor them, deploy applications from the cloud using technologies like Azure Arc. And so what we're seeing now is this realization that we have to have compute at the edge, but we want to follow the same paradigms that we follow in the public cloud.
Mm-hmm. Okay. So how is this different or similar to IoT, Internet of Things? Because it sounds like some of the concepts are similar.
Yeah, well, the way I think about it is that IoT is a primary use case of edge computing. And when I think about these use cases, they always include things like manufacturing, healthcare, oil platforms, military in some cases, which almost always includes some form of IoT. And I want to riff about this for just a second. IoT is actually a huge topic in and of itself. And IoT computing, when you think about it, it's evolved largely independent of enterprise IT. So it's got its own set of abbreviations like SCADA for supervisory control and data acquisition, and OPC UA, and MQTT. People have actually made the distinction between enterprise IT and operational technology, OT. Mm-hmm. And one of the things that's happening now is that because there's this common set of application paradigms and protocols and so on, Kubernetes, OpenTelemetry, Arc, Fabric, and so forth, you're starting to see the worlds of OT and IT come together. Mm-hmm. And so now we can build digital models of factories and simulate their operations with real data. We can simulate and predict failures of individual components and whole sites and so forth. So we're starting to see some really interesting scenarios evolve and develop.
Mm-hmm. Okay. So you brought up Kubernetes. So I'm thinking, okay, it's a little bit like IoT, but how is edge computing different from or similar to cloud computing? Because it uses some of the same paradigms, right? Like AKS, functions, all the things you were just mentioning.
Yeah, there are a lot of similarities, and that's a good thing, right? Because we have the
Right.
same programming models and same programming paradigms at the edge as we have on the cloud. But there's some very profound and if subtle differences. And the way I think about it is that the public cloud offers essentially unlimited computing, an environment without limits. You can scale, more or less ad infinitum. You're guaranteed super fast, very reliable networking, more or less unlimited storage, and so on and so on and so on. But the edge, it's very different. You have very constrained environments. You might have a cluster of 4 or 8 or maybe even one physical machines with some limited amount of storage, and that's it,
Hmm.
right? You have to design your workloads so that you don't exceed these limits. You can't scale out, forever. You might have unreliable networking. Maybe the network is inaccessible at certain times of the day. You don't have that in the public cloud. The network is always available.
Hmm.
Maybe a backhoe comes along and tears up the network cable in some remote location, and it takes a week for the repair crew to come out and fix it. You have to
Yeah.
design for these scenarios. So
Hmm.
you know about the Cloud Native Computing Foundation. They sort of the people that steward through the standards for all the cloud native technologies like Kubernetes and so on. They have a really good white paper on what they call edge native computing, where they talk about what it's like to what are the requirements of designing applications for these constrained environments.
Hmm. Okay. So I've been trying to follow along throughout my career with what Microsoft's doing in,
Sure.
cloud computing, IoT, edge computing, and I feel like lately they're changing how they talk about the edge and their strategy around edge computing. I feel like, they've always been saying cloud to edge. That's been kind of a refrain from them for years, but I feel like
Right.
their strategy is shifting now. Am I right about that?
Yeah, I think so. I mean, I think their view originally was pretty much like everybody else's, that everything goes to the public cloud.
Hmm.
IoT configuration comes from the cloud, telemetry goes to the cloud. So they built things like event hubs and IoT Central and so on to support all these things. And they're very clear that all these things are staying and they're not going away.
Hmm.
But I do think they realize this cloud only or public cloud only approach or centric approach has some disadvantages. So now you're starting to see a lot of services being offered at the edge, like SQL Server and AKS and Arc and Logic Apps, functions, to name a few.
Hmm.
And they've done some really cool stuff with this new service called Azure IoT Operations, which I think we're discussing in a minute. So, my sense is that Microsoft is actually way, way ahead on edge. And if we actually have time later, maybe we can discuss why I think this is a critical competitive advantage for Microsoft,
Hmm.
maybe even more than Copilots.
What? Okay.
Yeah.
You just gave me the perfect segue because I want to talk for a minute about Microsoft's favorite word these days, Copilot. At Directions, we've realized our customers and we analysts ourselves need help tracking the constantly growing family of Microsoft Copilots. The names keep changing, licensing changes, pricing changes, new co-pilots are announced almost every day, it feels like. So to help ourselves and others, we created a chart that pulls together basic facts for more than 30 business-focused co-pilots. Our chart gives you an at-a-glance understanding of each copilot, details the use scenarios, the training, customer data used, licensing costs, if we can find them, and dependencies on other Microsoft products. If you are already a Directions member, you can already access this chart, which we are updating regularly. And if you're not yet a member, you can still get a free copy of this cheat sheet by going to directionsonmicrosoft.com/Microsoft-copilots. Okay, back to Barry on the edge. Since I just brought up copilots, let's talk about edge computing and AI a little bit. So Microsoft and others are working on ways to help customers run at least some AI workloads on the edge, and there they mean locally on their devices for a variety of reasons. Um, After they run some jobs on the devices, they can go back to the cloud and do some processing. So I'm curious what you think about this new usage pattern, and will it change the edge computing landscape?
Yeah, there's an awful lot to unpack here, and
There is.
I'll say, things are evolving very rapidly. So, first of all, processing data where the data is created has a lot of advantages. So you can cut down on expensive network traffic, for example. Um, so, for example, you can capture a lot of telemetry, train a model, then download the inferencing engine to the edge so that it can respond instantaneously to events and alerts, automatically taking action, for example, if something's overheating, and for example, I always talk about, you have an IoT device, and every second it sends, "I'm okay, I'm okay, I'm okay." Well, there's no reason for that to go all the way up to the public cloud. You can just say at the edge, "Thank you very much, keep going," and maybe once a day, you send up, "I've got 1,440 I'm okay messages from this particular sensor."
Right.
But now with client-side large language models, you can run like Olama with Llama 3 or Phi 3, the SLM from Microsoft. Um, you can connect to local data sources. You can get edge generative AI, which can be used for local management, local problem solving, and so forth. It's really cool stuff. It's very bleeding edge, but it's really exciting. And I think there's a lot of runway here.
Hmm. I agree. I think we're going to hear more about this at Build, which
I think so.
which is
Looking
next
forward
week.
to it.
It is. Yeah. Yep. Okay. You mentioned Azure IoT operations a little bit earlier. So I'm curious, how does it compare to the products Microsoft had like IoT Hub, IoT Central, the other IoT cloud services? You said those aren't going away. So what happens in terms of IoT operations and these legacy services?
Yeah, so I think that Azure IoT Operations really highlights just how much Microsoft has matured in its thinking with respect to IoT. Now, IoT Operations, which runs on the edge, first of all, supports two of the most common IoT protocols, MQTT and the venerable but ubiquitous IoT protocol OPC UA, and allows you to build your own adapter using the Kubernetes extension framework ACRI if you want. And IoT Operations also has this really interesting new pipeline-oriented application model. So, as we were discussing before, I get the status OK message, and I can process it within a pipeline stage, and maybe send back an ACK to the device and say fine, and never bother the network or the cloud. Mm-hmm. So some very interesting new technologies that they're putting at the edge. Now, all this is still in preview. It was announced last November. So we'll have to wait to see what the GA version also includes. But I think it's an area where Microsoft has once again, in this case, demonstrated some maturity and leadership in the IoT space.
Mm-hmm. Okay. So what we haven't talked about is all the data, right? You got all these devices and they're generating a ton of data. So what happens here? There's going to be a lot of telemetry. Is it useful? How should people be thinking about this?
Yeah, so in the old days, a lot of that telemetry just went right into the bit bucket, and it was an enormous amount of data. The nice thing about edge computing is, as we've talked about, is that you can start to process all this data locally and then decide locally what needs to happen. So we can do maybe predictive analytics, we can do predictive maintenance, we can track, for example, a sensor to see, hey, you know what, this is the temperature of this device is going up by a degree every day. We've got about a month before the thing's going to fail, so we can send out, service rep or whatever, do predictive maintenance, do preventative maintenance in advance. And what does that mean? Well, that means that our uptime of the whole system is improved. It means that ultimately that profitability is improved, productivity is improved, and so forth. So it has a lot of downstream effects, that are all positive as well.
Okay. The other thing you hear about all the time when people are talking about edge computing is digital twin. I feel like for a while Microsoft was talking a lot about this, and maybe a little bit less so now. But how does this all fit together with what edge computing is? Edge computing and digital twins.
And that ties into our previous our previous question about telemetry. So what can you do with all this telemetry? So a digital twin is basically a software representation of some sort of physical asset, and usually digital twins run on the public cloud, or they don't have to. And the whole idea is it allows you to monitor physical devices, allows you to model them, you can do simulations on them, and so forth. And there's a whole set of standards and interfaces that have evolved over the years for building such things. So you can build digital twins that consist of components which are interoperable.
Mm-hmm.
And so so you can give me for example, Barry. So for example, you could use these declarative formats to define each component of a factory assembly line. For example, the hydraulic press we were talking about before, and then you can connect them in software to simulate the entire assembly line, and then connect all the assembly lines to simulate the entire factory, and then model logistics for the supply chain and so on. So at the end of the day, you could see, for example, the impact of a storm in the Pacific, delaying the arrival of a container ship with supplies. Or you could see if the telemetry starts indicating, certain conditions, how that affects, the device, a particular device, and how that has the downstream effects, as we talked about, maybe affecting the operation of the assembly line and the productivity of the factory, and ultimately a profitability for the company and so forth. So digital twins are something that as we merge these areas of IT and OT, become increasingly important that we have this unified view of the whole enterprise.
Mm-hmm. Okay, that's good. To close, I want to ask you, because you've mentioned this a couple times in passing, that you think Microsoft's ahead in this space. Why do you think that? And I guess I'm curious, because I feel like I would say their strategy changing made me wonder if they were trying to catch up to someone, but you sound like you believe they actually have kind of got their act together in this space.
Yeah, I do think they have their act together, and I think that they've made that realization that there's stuff that should be processed at the edge, and there's stuff that should be processed in the cloud. Whereas the other cloud vendors still think, by and large, that all the processing happens in the cloud. So I think that may ultimately result from Microsoft's long history in enterprise computing generally, and a long association with very large manufacturers, and other enterprise customers that need this and use this kind of stuff. So I think that's probably where that all comes from. I'd also say that as we start to see the generative AI become commoditized, and we are seeing that. How many LLMs are there out there, these days? Dozens and dozens and dozens, and you can run them on your desktop and do interesting things. As we start to see they're being commoditized, what becomes this competitive advantage for Microsoft? Well, once you put these edge devices in and they're running your factory, they're pretty well entrenched.
Right.
The switching costs become, are pretty substantial. So, the fact is that you've got a vendor here who really understands the stuff. It works. You put it in, and then it's just going to stay there forever. So, I think as a long-term bet, it has a lot of competitive advantage.
Okay. Well, thank you so much for our whirlwind tour of the edge today, Barry. I really appreciate the time.
It was my pleasure.
To close, I want to remind our listeners they can find lots more coverage of all things Microsoft related over on directionsonmicrosoft.com. Thank you for listening. If you have questions, comments, or any topics that you'd like to hear the Directions Analysts cover in one of these podcasts, please do not hesitate to contact me via Twitter at Mary Jo Foley. And speaking of Twitter, give us a follow at DirectionsMSFT for all the latest Microsoft Enterprise product and licensing information. Thanks again.